Hello and good day. Alright, so today we're going to talk about maneuvers and some of the information that's available on the Maneuvers tab. As you'll notice, we can create launch windows. We have a section for orbit criteria and then a section for maneuvers, including Hohmann, combined plane changes, and simple plane changes, as well as some other additional information. Down here just showing the orbit information. All the information over here on the left under staging I'll let you play with, but it basically allows you to pull down various information, propellants, etc., to determine delta V requirements and mass requirements for staging and transfers. All that information is on the right of the tab. I have input some key propellants, and then you can add your own if you desire. You'll notice here under the orbit section you are able to pull down the colors for the orbits for maneuvers, for the initial orbit, transfer orbit, and the final orbit, as well as the orbit for the simple plane change. Currently the phasing orbit section has not yet been incorporated. That's pending with Rendezvous. I'm going to show you really quickly how to generate a launch window. As you'll notice, we have the launch site, which is Colorado Springs, Colorado, and some of the other key information there. You can see the definition in the comments. Under start time, you'll see the time for the start time is linked to the date and time tab, cell C6, which is the main scenario time for the workbook. You can change that if you'd like, but just remember that if you want to revert back to the scenario time, it refers to C6 for the date and time tab. And we'll keep it that way for today. You can move it forward or back in time to show whatever launch windows you want. I've shown 4 opportunities here, an ascending node and descending node opportunity, and the first respective opportunity and the follow-on opportunity. So let's try the ascending node at the first opportunity. It's highlighted in green here. I will hit generate window, and it will then cycle through and generate the launch opportunity. Alright, and now you can see when we go back to Google Earth, I've already brought this in from the desktop. We're going to right click and revert, and you can see the location of the ISS at that time and the position that you must be at in order to launch into that orbit. And then it's just a matter of rendezvous operations, which I haven't yet incorporated into this workbook. As you can see, it says the first ascending launch window. So let's go back. We're going to do the second descending launch window. You can see it's highlighted down here. Hit generate window again, and it will do the same operation and cycle through. Okay, and now that we're back, let's hit Google Earth and right click, revert, and now it shows the second descending launch opportunity. That is where the ISS will be, and this is your launch site, and it shows your positioning to get into that orbit. I do want to highlight that I am doing this for the ISS, but if you were to go back to the Orbital Mechanics tab and choose any of the manual TLE information, it will then be available to you, and you can generate launch windows for those as well. Okay, now that we've got that complete, I'm going to talk about maneuvers. We're going to start with the Hohmann transfer. As you can see, the orbit criteria is over here on the left, and that information can be changed from the Orbital Mechanics tab. Once again, hit Manual TLE and you can change that, but we'll just keep it at the ISS for the time being. If you want to change any of this orbital information, the follow-on or final orbital information, you can then change it. And I have selected the inclination to decrease by 15 degrees and right ascension in the ascending node to increase by 20 degrees just randomly. And we're going, say you want to take the ISS out to generally 42,164, roughly GEO, and let us click Home and Transfer. And it's going to then do that cycle really quickly. And now that it's complete, let's go back to the desktop, and it is now under Home and Burn. And there you have it. That is our LEO to GEO Hohmann transfer, showing the complete orbit. There is also an opportunity to show the partial transfer orbit. So let's show you what that one looks like really quickly. And that is complete. Right click, revert, and there you go. Now it shows directionality for launching into a Hohmann. This is currently the current position of the ISS, and then you can see each of those initial orbit paths where those orbits begin and end. Let's go back. Now we're going to go to a combined plane change with a Hohmann transfer. And there are a few options here. If you want to do all of the plane change at apogee at the end of the burn, you can do so by having that at 0. But let's optimize that plane change. We have a total plane change of 20.3315 degrees. We're going to optimize the plane change. And because it's a large orbit, it's got to go through, and it will take a few seconds to find the optimum place where delta V is minimized. And there it is. So let's hit Combined Plane Change, Hohmann Transfer. And it is now cycling through that as well. Okay, and now that it's complete, let's go back to the desktop. I'm going to right click Combined Plane Change and hide the ISS Hohmann Transfer. And now you can see the combined plane change for what that would look like for a LEO to GEO combined plane change, with the majority of the plane change occurring at GEO. Alright, we're going to try one other option. Now we're going to do a simple plane change. It'll essentially do the same thing. We'll have the original Hohmann transfer, but a simple plane change on top of it. So let's click that. And it is now generating, similar to all the others. Okay, and now that that's complete, let's go back to the desktop. Simple PC. And let us hide the combined plane change. And now you can see there is the simple plane change maneuver, which would be used in conjunction with the previously created Hohmann transfer. And one other final thing to note, on the right side there is some delta V information in the RIC frame. That's radial, in-track, and cross-track. It's basically a way to track delta V maneuvers in all 6 directions. We're going to go back to the Satellites tab. And for now, that concludes this lesson on orbital dynamics calculations. Please join us for the next time. Thank you.